The cosine rule is another rule we use for finding missing angles and lengths in general triangles. So we either have the sine rule or the cosine rule. Sometimes we would prefer using the sine rule. Sometimes it's only possible to use the cosine rule. So it really depends on the question. And we can still use it for right angle triangles just like the sine rule, but we already have the trig ratios for the right angle triangles. Now, there are two forms of the cosine rule, just like the sine rule, but for the cosine rule, it matters which form you use depending on what you need to find. For the sine rule, it's a bit more flexible. So I'm going to explain each one. There is a more detailed video on the cosine rule that you could watch with more worked examples in there if you need to. So this only has two examples and brief explanation. Before we move on, labeling the triangles, this is similar to the sine rule explanation. So if you have a triangle, we label the angles with capital letters A, B, C, and the opposite lengths will be lowercase. So this opposite A, that will be lowercase a, lowercase b, because this is opposite to the angle B, and lowercase c, that's opposite to the angle C. Now, you don't need to have these specific letters. It could be PQR and then lowercase pqr, it's up to you, but make sure that it matches the question. As I'm going to show the cosine rule, it's important to note that yes, maybe we're using the A, B, C letters, but in your question it might be different. And I'm just going to show the main important thing that you need to note in each form. So this is the first form. And the first thing you need to notice is the A in here. So if A is the missing length you need to find, then the cosine has to be the opposite, the angle opposite to it. So you need to make sure that you match these. Now, B and C, it's the rest of the B and C, that's just going to be the lengths, and it doesn't matter which one is B and which one is C. But you need to make sure that the angle you put inside the cosine is opposite the length that you need to find. So this is the main important thing. So even if your labeling is not ABC, maybe it's PQR, and maybe R is the length that's missing, then make sure that the opposite angle to R is the one you put inside of cosine. So you also need to remember to square root your answer, because the formula gives you A squared, it doesn't give you A. So this is the way we write it, just because writing square root is going to be too cumbersome. So once you use this formula, make sure you always square root the right-hand side, because this is A squared on the left-hand side. So as I'm mentioning here, the most important thing is the angle opposite. And for B and C, it doesn't matter which ones you select as B or C, as long as your A's are correct. The other format is this, which is for the missing angle. So it's kind of a rearrangement of this first form, but again, you need to be careful of this A. If A is your missing angle, then you have to select the opposite length as your A here, and has to be subtracted from the B and C. Again, as you notice, it doesn't matter which one's B, which one is C, because you're adding them together and squaring them, and even in the denominator, you're just multiplying them. But the A matters because you're subtracting it, so you need to select the correct A, and the correct A is basically the length opposite your missing angle. So again, if P is your missing angle, then the opposite length to P will be the value you put in here, squared, and it has to be subtracted. So again, just like the length format, with the angle format, this is not the final answer. You have to take the cos inverse. So once you've done this right-hand side, your final step is to take cos inverse of this right-hand side, and that's going to give you the angle A, because this formula, this right-hand side, only gives you cos A. It doesn't give you A. In order to get A, you have to do cos inverse. So kind of similar to the sine rule. And again, note that the length opposite missing angle, that's what you need to find. And the same thing, it doesn't matter which B and C you pick, as long as obviously they're correct lengths, but it doesn't matter which order you select B and C. So again, once you use it, if you have a missing, if you need a missing angle, you need to have all three lengths, because if you notice in the second formula, you need B, C, and A, so you need all the lengths available in order to find the missing angle. If you're missing a length, you need to have what I call a sandwiching situation. So you have two lengths and the included angle given. So it's like you have this length and you have this length, and what's missing is, and you have this angle as well. So you have three things. If you have this sandwiching situation, it means that you are missing this length, and you can actually use the cosine rule. So sometimes, and actually, I go through the cosine rule checklist, and if the cosine rule doesn't fit, I use the sine rule. So I have this example, I have triangle ABC, and I have these lengths and this angle. I need to find the length. So what I'm going to do, I'm going to first draw my diagram. So any way you want, you could have drawn it differently. So AB is 6.3, AC is 8.6, and the angle at A is 50. So I can see that I have a sandwiching situation. And the thing I'm missing is BC, so this is missing. So if I label this B, A, C, so I have this sandwiching situation here. So I have a length, and an angle. So I can use the cosine rule. So this is my formula for the missing length. And I'm going to note that if I'm missing angle length A, I need to substitute the correct opposite angle, which is 50. So I'm going to do that. I'm also going to substitute my B and C. And I'm going to make sure that I square root the right-hand side. And that's going to give me 6.633 meters. So that's just simply using the rule, which rounds to 6.6 meters. Now, what if I'm missing an angle? So I'm going to explain one method, but the question requires you to find A, B, and C. So I'm going to briefly explain just how to do it for one angle, and then you can pause the video and try the rest of the angles. So as you can see, if I'm missing an angle, I need to have all three lengths, which means I can use all three lengths to find any of the angles. So in this case, let's say I'm trying to find cos of A. So let me finish my labeling here. A, this is C, this is B. And if I'm trying to find angle A, then I need to make sure, be careful, even though it looks like a right angle, it's not necessarily a right angle. So if I'm trying to find the angle A, I need to subtract the opposite length, which is 14. So notice that I'm subtracting 14. So that's something to be careful about. And then this is my B and C, or yeah. And then if I simplify it, I need to make sure that I get rid of this cos, so it's going to be cos inverse of this whole thing, which is basically what your right-hand side was. And if I do cos inverse of this whole thing, it's going to give me 91.0, so actually very close to 90 degrees, but not quite. So we can do the same thing for B, and notice how I am substituting the opposite length to B, which is 12. So I'm subtracting 12 squared here. And then the same thing, I take the cos inverse of that, and that's going to give me 59. I can use these two angles, do 180 minus these two to find the angle C, or you can practice using the cosine rule. So again, I'm using the cosine rule, and I'm subtracting the opposite angle, which is 7, and then the rest are my other angles. And I'm going to get this. Make sure you take the cos inverse, and that's going to give me 30. So again, yes, the formula said it said B squared plus C squared minus A squared. It doesn't matter what these letters are. It doesn't matter, because if you notice in these questions, it's basically A squared plus B squared minus C squared. So yes, it's not the exact same format, but what's important is all you need to make sure is that if this is my opposite angle, then I'm subtracting the opposite length, and then the rest of my lengths go here. So notice how I'm not even using the letters A, B, and C. So hopefully this was clear. If you need a more detailed explanation, there is a cosine, more in-depth cosine rule video to go through.